Let's get real.
Welcome to the Daniel Stee Podcast. If you've ever looked at lithium battery fires on airplanes and thought, this doesn't quite make sense, but everyone seems to accept it, this episode's for you. I'm not here to argue, alarm people, or rant about safety. Just want to give you a clear way to think about this problem so you can decide for yourself what actually holds up. And by the end of the episode, you're going to walk away with one simple mental model you can use anytime this topic or something like it comes up. Are we treating the cause or just managing the moment of failure? Failure. Because once you see that distinction, a lot of current aviation policy suddenly looks incomplete. The trigger event. What keeps happening? Every so often, we see the headline. A phone catches fire in the cabin, a power bank overheats, a flight diverts, and the response is always the same. New passenger rules, containment equipment, reminders not to charge devices or leave them on in overhead bins. And from the outside, it might seem like this is progress, but under the hood, something strange is happening. We're adding more and more after the fact defenses while barely asking, why is the failure happening in the first place? So the assumption everyone is operating under, what it's built on. Here's the assumption most people and most policies are built on. Battery fires are rare, random accidents caused by careless passengers. The solution then becomes control passenger behavior, train the crews better, and contain the fire once it starts. That sounds reasonable, but it quietly shifts attention away from the system that creates the risk and towards the people who happen to be nearby when it fails. So what's actually causing these fires? Lithium-ion batteries catch fire for one reason. It's called thermal runaway. These batteries store a large amount of energy in a very small space, and if the internal temperature crosses a critical threshold, the chemistry starts feeding itself. Once thermal runaway starts, it can't really be stopped. The battery generates its own, and it can reignite even after you suppress it. This is well understood engineering behavior. And importantly, the triggers are predictable. Heat can build up from heavy loads or poor ventilation, overhead bin, aging cells, battery cells, the internal resistance rises, manufacturing defects. It could sit dormant for months, physical damage, so it doesn't fail immediately, and low quality, counterfeit replacement batteries. None of this is random. These are design level failure modes, not passenger mistakes. Here's how aviation handles it today. To be clear, aviation does not ignore this risk. Cabin crews are trained, fire containment bags work, and diversions can save lives. But notice what all of these measures have in common. They activate after the battery has already failed. At that point, the device may be molten, toxic smoke may be spreading, and reignition is still possible, and the aircraft almost always diverts. That's not prevention. That's emergency response excellence. And those are not the same thing. Here's the key insight. The mental model. Here's the lens I want you to keep. Containment manages the consequences. Design standards reduce the probability. Fire extinguishers don't mean wiring standards don't matter in a house. Seatbelts don't replace crash worthiness for cars. An emergency oxygen mask in an airplane don't make the cabin pressurization optional. Aviation safety always has advanced by moving risk controls upstream. Lithium batteries are one of the few areas where we seem to have stopped short. Why treating all batteries as equal is the real gap. Here's the uncomfortable truth. Not all lithium batteries are equally safe. But in aircraft cabins, we treat them as if they were. A brand new, tightly controlled battery and a degraded counterfeit replacement are functionally invisible to the system. That's unusual in aviation. Almost everything else on board, materials, components, structural elements, fire-rated interiors are held to aviation Pacific standards. Batteries somehow got a pass. So a design-based solution, without policing the passengers, would be, here's the idea, not a mandate, it's just a direction. An aviation-safe battery certification. Not chemistry inspection at security or banning these devices or searching bags. This happens at the manufacturer level where safety belongs. An aviation-relevant standard would focus on things like internal short-circuit tolerance, separator integrity, controlled failure behavior, reduced propagation between cells, traceability. And enforcement wouldn't be punitive. It could work the same way aviation already handles countless other rules. Certification is tied to privileges. Charging is allowed for certified devices. Fire containment stays, but it becomes a backstop, not the first line of defense. So why hasn't this happened yet? The barrier isn't technical, it's incentive-based. Stronger design standards mean increased manufacturing cost, shift liability, you create a visible flight safe versus not distinction. Because containment bags are cheaper, rules are faster, it's faster to just make a rule, and neither require industry-wide alignment. But they also leave the underlying failure rate untouched. And here's why this matters beyond batteries. If this feels familiar, it should. We see the same pattern in healthcare, banking, climate policy, technology regulation. We manage symptoms because they're visible, and we defer structural fixes because they're harder. It's just how complex systems drift. So the next time a lithium battery fire shows up on the news, here's the question to ask. Are we reducing how often failures happen, or just getting better at reacting when they do? Current aviation policies, excellent at response in terms of batteries. The next safety leaps comes from design, and aviation history is clear on this part. The biggest safety gains always happen upstream. Lithium batteries shouldn't be the exception. If this way of thinking resonated with you, I've written a companion article that goes deeper into the mechanics and design implications. And you don't need to agree with the solution. The goal is to simply see the system more clearly. The link's in the description. Thanks for listening. I'm Daniel Stee.
Let's get real.